Hello, good evening, everybody. Welcome to today's class. Last week we started with what is called data structure. We started with data structure last week, and today we are still going to continue from that. Okay, we made mentions of some things last week when we were talking about data structure. We started with the definition of data structure, and we are made to understand the essence for this is so that you understand. We started before now. We started with our database design, database structure, database management. We talked about your schema and everything. All in all, we're just talking about how data are being used, how they are being initialized, the logic that is, or the logic and the operation which goes on in your database. Now, for your database structure, for your data structure now, your data structure now is helping you to understand that for all this information of all the information which you've already known in database, how these things, how they are being implemented. Data structure is now telling you that how these things are being implemented, because you get to understand that in your database contains of different operations, different functions, different informations, different characters, and understand that the way these characters, all these operations, the way they are being handled are different. They are different. So we started with what is called definition of your database, of the definition of data structure. So we're meant to understand that in computer science, a data structure is a data organization, management, and storage format that enables efficient access and modification. So with the use of your understanding data structure, it aids you or gives you the privilege for you to manage a database. It gives you the privilege for you to manage a database, organize a database, how to store information effectively, and and also afford you the privilege of modification in a database. So understanding data structure gives you the advantage of that. So that is why it is being said that a data structure is a data organization, management, storage format that enables efficient access and modification. More precisely, a data structure is a collection of data variables. The relationship among them and the function or operation that can be applied to the database or to the data. Now, a data structure is a specialized format of organizing, processing, retrieving, and storing data. While there are several basic and advanced structure types, any data structure is designed to arrange data to suit a specific purpose so that it can be accessed and worked with in an appropriate way. So you understand that there are different kind of data structure. You have your basic data structure and you have your advanced data structure, data types. So I'm understanding how all these things operate, understanding the intricacies of all these things gives you the privilege to understand how a database itself works, or it gives you the privilege to also understand how to maneuver or to go around a database, because your database is full of data, full of informations, full of different characters, and the operations among them are different. The way each character or the way each operations are being handled are differently. So with when I gave an assignment last week for you to write the data structure hierarchy, your data structure hierarchy. Or your data structure hierarchy, you have what is called the primitive data structure and the non-primitive data structure. I believe so many of you did that assignment. So in your primitive data structure, we had some things that talking about your flat, your charts, your boolean, and your integer, and the rest of them. So all these things, the way that they are being handled and the operation amongst them are different. That is you have to take note of that. The operations amongst them are different, and the way they are being handled are different. So now, a data structure is a practical way of organizing data in a computer so that it can be used effectively. I repeat this again. A data structure is a practical way of organizing data in a computer so that it can, it's a practical way of organizing data in a computer so that it can be used efficiently. For example, we can store a list of items having the same data type using the array data structure. So an array data type is a type of data structure that you use to store items chronologically. That is, when I mean chronologically, that means the once an information is being updated in the list of array, the information that is updated comes on top, and when another one is being updated and information is being imputed again, the first one, the previous one goes beneath, and the new one that is being inserted comes on top. That is a chronological arrangement. So that is how a data is being stored in your array data structure. So just like it's been said, a data structure is a practical way of organizing data in a computer so that it can be used efficiently or effectively. Now, what are the usage? What are the usage of your data structure? What are the usage of your data structure? Now, understand that data structure serves as the basis for abstract data types. Your data structure serves as the basis as your abstract data types. Now, what is abstract data types? Abstract data types defines the logical form of data type. The data structure implements the physical form of a data. Different types of data structure are suited to different types of data structure are suited to different kinds of application, and some are highly specialized to specific tasks. For example, relational database commonly use what is being called a B-tree index. A B-tree index for data retrieval, while a compiler implementation usually use hash tables to look for identifiers. So these are the two different, these are the usage of data structure. So for a relational database, when we're talking about database, we talked about different kinds of database. So for your relational database, a data type that is being called a B-tree, that is what is being used. It is being used for what is called data retrieval of indexes. Then this is actually a kind of operation. It is a kind of operation that solely can be carried out by a B-tree index. So for data retrieval, you should know that what is being used for a data retrieval is B-tree index. This is actually a task that can be only performed by B-tree index. Then for identifiers, compilers identifiers, what it is being used for is for your hash tables. For your hash tables. Please take note of that. Data structure provides a means to manage large amount of data efficiently for the use of large database. So you can use, with the aid of data structure, it gives you the advantage to manage a large amount of data. Take for instance, in a large data base, or an internet indexing service. So with the aid of data structure, you can actually manage a large database or a internet indexing service. Usually, effective data structure are key to designing effective algorithm. So if you really understand your database, designing of your algorithm won't be of an issue to you. Understanding data structure gives you the advantage of knowing or of understanding the way to analyze and structure and bring out a good algorithm. So because you understand, for your algorithm, you need different kind of variables. So if you really understand a problem very well and you understand data structure also, so with the aid of your data structure, viewing a problem, you should be able to analyze it very well, and at the end of the day, bring out the variables, the suitable variables, bring out the operations which these variables need to be carried out upon, and you bring out the tasks which are to be carried out. So understanding data structure gives you the advantage of making out and drawing out a good algorithm. So now, some formal design method and programming language emphasizes data structure rather than algorithm. So if you really understand data structure, your algorithm is more like a walkover. Understanding data structure makes algorithm to be a walkover for you, because you understand, you will take note that in trying to understand a problem, a given problem, you discover that you are actually dealing with data structures. You are actually dealing with data structures, and you understand when your hierarchy of data structure, in your hierarchy of data structure, you have your primitive and non-primitive data structure. Under your primitive data structure, you have what is called your integer, your float, your boolean, and the rest of them. For your integer, you know that your integer takes numbers. That is numbers that are a whole, that you call them whole numbers. Then your boolean takes true or false. Then your float takes decimal numbers. So if you really understand the data structure, it will give you the advantage, it will give you the leverage of understanding how an algorithm needs to be implemented. That is why you discover that some people understand, some people find it difficult in implementing simple algorithm. The reason is because of their knowledge in data structure is not solid. So the essence of this course is so that we understand our data structure very well. Once we are able to understand our data structure, dealing with algorithm now will be a walkover for us. So that is for that. Okay, just like I said, I said before, some formal design method and programming language emphasizing on data structure rather than algorithm, as they are the key organizing factor in software design. Data structure can be used to organize the storage and retrieval of information stored in both the main memory and secondary memory. So with the with you understanding data structure, it gives you the leverage to understand how to allocate memory space for operation, allocate memory space for our discovered when we were talking about our algorithm. We talked the factors that affect your algorithm is what is called your time complexity and your space complexity. You will discover that you cannot simultaneously maximize both of them at the same time. You cannot simultaneously maximize both of them. So with the aid of data structure, you should be able to understand management and space management. That is why you discover that most of the times, those people that are very grounded in data structure, maximizing of algorithm is very, very easy. They know how to allocate the number, they know how to allocate proper time and space factor for algorithm, because we all know that both of them cannot be maximized at the same time. So with the aid of your data structure, you could be able, data structure avails you the opportunity to organize your information or your data in such a way that they can be stored and retrieved. They can be stored and be retrieved both in the main memory and your secondary memory. I believe that by now we should have known what is called main memory and secondary memory. Now, what are the implementations? How is data structure implemented? How are they implemented? Now, take note of this. Take note of this. Data structure are generally based on the ability of a computer to fetch and store data at any place in its memory. This is how data structure are being implemented, the implementation of it. Data structure are generally based on the ability of a computer or a system to fetch and store data at any place in its memory, specified by a pointer. So what is being used to fetch and retrieve memory, to fetch and retrieve data from the storage is what is called pointer. Now, what is a pointer? A pointer is a bit of string. A pointer is a bit of string representing a memory address. So a pointer is actually indicating the address where an information is residing. And one thing you should note that, one thing you can also note is that they can be, it can be stored in the main memory itself. It can be stored, that is the information which you are actually looking for. It can be stored in the main memory and can also be manipulated by the data. Okay? So that is for that, for pointer. A pointer is a bit of string representing a memory address that can be itself stored in the memory and manipulated by the program. That is what a pointer is. And data structure are generally used or are generally based on the ability of a computer to fetch and store data at any place in the memory specified by a pointer. That is the implementation of your data structure. Now, a pointer now is a bit of strings representing a memory address that can be itself stored in the memory and manipulated by a program. The implementation of data structure usually requires writing a set of procedure that creates and manipulates instances of data of that structure. The implementation of a data structure usually requires writing a set of procedure that creates and manipulates instances of that structure. The efficiency of a data structure cannot be emphasized, cannot be analyzed separately. The efficiency of a data structure cannot be analyzed separately from those operations. That is, the operation which has to be carried out, the operation which has to be carried out is not different from a data structure itself, because you understand that the operation itself is part of the data structure. That is the iteration that needs to be carried out, the operations, or the operation now means the place which information needs to be fetched and what to do with this information. All this operation itself is part of the data structure. So that is why it is being said that the efficiency of a data structure cannot be analyzed separately from those operations. This observation motivates the theoretical concept of an abstract data type. A data structure that is defined indirectly by operation that may be performed on it, and the mathematical properties of those operations, including space and time cost. So in general, understand that the operations that need to be carried out, you cannot separate it from a data structure itself. The reason is that in whole, the whole operation, the data that are being used, the data that are being fetched and are being manipulated, all of them constitute in the data structure itself. So mathematically, you cannot, before that or with everything being in place, it has actually given the motivation that the concept of data type, the concept of an abstract data type. Remember that we made mention of an abstract data types when we started earlier. So all these mathematically are pointing, and the properties of the operation are pointing to the space and the time cost. Okay, now what are the characteristics of a data structure? Characteristics of a data structure. Now, characteristics of a data structure. Data structures are often classified by their characteristics. The first characteristics of a data structure is what is called linear and non-linear. The first characteristics of a data structure is what is called linear and non-linear. Non-linear characteristics of a data structure determines whether the data items are arranged in a chronological sequence. The characteristics of a data structure now being linear or non-linear, it describes whether a data item are arranged in a chronological sequence, such as with an array, or in an unordered sequence, such as with a graph. So when a data item is being arranged in a chronological sequence, when a data is arranged in a chronological sequence, just like I said before, it's called an array. Array, and data item that is arranged with an array, information are being arranged in a chronological order. That is, every newly updated information comes on top, and the previous one goes beneath it. Then, if it is, that is what is called in an ordered form or in a sequence form. But if it is in an ordered form, that means if it is not in a sequential form, it is not in an orderly form, then you can say that such data item is being arranged in a graph form, such as with a graph. So that is what is being called, that is the first characteristics of a data structure, which is linear and non-linear. Then the next one is the next characteristics of a data structure is what is called homogeneous or non-homogeneous. Homogeneous or non-homogeneous. This characteristic describes whether all data items in a given response stream of the same types or of various items or various types. This characteristic describes whether a data item are in a given response stream or they are in a different types. That is, this type of characteristic, which is the homogeneous or non-homogeneous, it gives any item or data item that are any data item that are in a one singular function or one singular operation, they are being called homogeneous. But when they are in different when these data items that are to be carried out are in different operations, then you call them non-homogeneous. Then the next characteristic of a data structure is what is called static or dynamic. Static or dynamic. This is a kind of data, this is a kind of characteristic that defines whether a data structure have a fixed size or not. So you could determine when a data item is fixed, it is called static. But when it is not fixed, it is called dynamic. So this is another type of another characteristics of a data structure. Now, what types of data structure? Last week I said you should write on the assignment. You do an assignment on the hierarchy of data structure. I believe that most of you must have done it. So very few of what I will be saying now will not be sounding funny to you. Okay, now data structure types are determined by what type of operation are required or what kind of algorithm are going to be applied. So depending on the type of item, data item, or depending on the type of data structure, the type of data structure determines the type of algorithm that needs to be carried out on it, or the type of operation that needs to be carried out on it. Take note for data types like your primitive data type. Under your primitive data type, you have integers. You have your integers, which are numbers, whole numbers. Then you have your floats. Floats are called decimal. Then you have your boolean. Your boolean are true or false. The kind of all these data types, the kind of operations that needs to be carried out on them are different. You can't use the data. You can't use the kind. Okay, take for instance your integer and float. Similar, the same kind of algorithm, that kind of operation can be carried out on them. But take for instance something like your tree. Tree is a data type. What is it called? Graph is a data type. Your graph and tree. You can't use the operation that can work on your integer or your float to operate on your tree or your graph. They are different. They can't work on them. So now, data structure types are determined by what data types of operation are required or what kind of algorithm are to be applied. first data type here is array. The first data type here is array. What is an array? An array stores a collection of items at adjoining memory location. An array stores a collection of items at adjoining memory location. Then another type of data, another type here is what is called a stack. Stores information or stores items in a linear order. A stack stores information or data items in a linear order, and operations that can be carried out on them is being called LIFO or FIFO. LIFO is called last in, first out, and FIFO is called first in, first out. So for your stack data type, the type of operation that can be carried out on it is called LIFO and FIFO. Then we have queue. A queue stores a collection of items similar to a stack. However, the operation order can only be in FIFO, which is first in, first out. A queue is actually very similar to stack, but for your queue, the operation that can be carried out on your queue is just in a one direction. But for in your stack, information operation can be carried there in two directions, which is your LIFO or your FIFO. LIFO means last in, first out. Then for your FIFO means first in, first out. Okay, now the last one here is called linked list. Linked list stores a collection of items in a linear order. Each element or node in a linear list consists of a data item. So this is how far we can go for today. Perhaps when we come next week, we'll be viewing some other things. Perhaps we'll view some important things which we have to take note of your data structure, because you understand that when in studying computer science, the fundamental of computer science is your data structure, because most of the time you discover that if you are not being able to, if you can't be able to solve problems, if you can't be able to solve problems, one of the issues or one of the things that might go wrong is that you might not really understand your data structure. When you fully understand your data structure, it becomes easier for you to pick up new programming language to study them. So understanding data structure is very, very paramount. It gives you the advantage to know how operations, to know how data structure are being handled. And for this, for the way they are being handled, operations are actually very peculiar to each and every one of them. So this is where we'll call it a day for today. So before the class comes to an end, we give an assignment, and that assignment is going to be, the assignment which I will give for today is for your data types which I have listed, which are the data types which I have listed, which are the arrays, stack, queue, and linked list. Write out the type of operation. Write out the type of operation that can be carried out, or write out the kind of operation that are peculiar to each of them. I mentioned 4 types of data structure: array, stack, queue, linked list. Array, stack, queue, linked list. For these four types of data structure, write out the kinds of operations that are peculiar to them. Write out the operations that are peculiar to them. This is our assignment for today. I made mention of four types of data structure, which are the array, stack, queue, and linked list. So these four data types which I've mentioned, write out the operations that are peculiar to them. Write out the operations that are peculiar to them. So I will give room for questions now. It's time for you to ask questions. Questions? The email still remains sharonchris29@gmail.com, and you can actually reach across my mobile on 081321 Please, questions. I am hearing some noises. Please, if you ask question, please make it snappy before our class is being terminated. Okay, this at this junction we've come to the end of today's class. In case you did assignment, please get across to me. Please get across to me. This well today's class. Thank you very much and have a lovely good evening.
Hello, sir.